Hello everyone. Something that has been on the tip of my tongue or at the forefront of my mind recently is layer 2 network design. So I thought I would do a short video, probably a Visio as well at some point, but a video on layer 2. Now, with layer 2, something that most of my videos are targeted at the CCDE students and people who are going for the CCDE. So when I talk about layer 2, I'm really talking about a mixture of CCDE level layer 2 in the enterprise, if I can spell it correctly, and then also in the service provider space. And the reason that I'm mentioning that specifically is because these two are very different from each other. So I'm going to give you 3 examples of layer 2 being used in the enterprise and the service provider space. So I'll do one service provider and one enterprise scenario, and then one scenario that could probably be a hybrid between both of them. The first scenario that I'm going to talk about is why we might need layer 2 in a enterprise scenario. Okay, so let's imagine that we have a wide area network and then we have 2 links into a site with routers, which are these devices that I've drawn here if you're new to networks or network design. These routers are effectively the gateway to the outside world, i.e. the internet and different websites and also applications that might be hosted in data centers. So what we mean by applications is ERP, CRM, intranet, and so on. Now these routers are then typically connected to a local area network. So let's say that we have 2 switches. We won't say what kind of switches they are at the moment, but let's say that they are 2 different switches, like physically different switches. And when we say 2 physically different switches, they might be stacks times 2 or units times 2, as in single unit switches. The main thing that we want to understand is that they are completely separate, so they are not a single stack, as in one virtual switch. Okay, so now if we have the clients on the network, which are down here, PC or whatever, and that has an IP address of 10.1.1.101 and a default gateway of 10.1.1.1, and that 10.1.1.1 needs to reside on these switches, this switch layer. Okay, so what we might do is from this switch layer have a single VLAN, if that is VLAN 10, and when we have VLAN 10 in play, let's call this a green VLAN, and that's the data VLAN which the PC is connected to. It's just an arrow pointing to this PC. What we then need to decide is that we have VLAN terminated into this switch and this switch. So therefore, if we want it to be a true VLAN and broadcast LAN, we also need some kind of connection between these so that we don't get a split brain scenario. Now, because this is a CCDE level video, I expect you to understand the workings of spanning tree protocol. And as a result of that, I'm just going to give you a little point in the right direction and say that in this type of scenario we used to use in the olden days, I suppose, it's probably not that long ago, but maybe 5 or 6 years ago, it was fairly common to use span and tree protocol or rapid span and tree protocol plus HSRP. And even if we didn't use HSRP, we used span and tree protocol or rapid span and tree protocol or whatever as a backup or fail-safe against loops. Now, what I would like you to do as a CCDE student is go and investigate as to why we would do that. But to explain how it would actually work, from a span and tree perspective, what we would do is we would set one of the switches to have something like a span and tree root priority of 8192, and then the other switch to have something like 16384. Now, I'm not going to tell you all the answers in this video because I think that you should go and find that out yourself. What we would also then do is, from a HSRP perspective, I'll say HSRP priority, which the default is 100. If you just enable HSRP on this router and this router, or this switch, these two switches, to talk HSRP between each other, the default will be the priority of 100, but what we want to do is set one more preferred. So this one, we might set the priority to 110, and this one we might just leave it at the default. Okay, now if we switch back to the topology, so effectively what we've got is here some kind of like routed port. The black is the physical connectivity. What we have here now, if we look at the traffic flow for this PC and concentrate on the blue line for the traffic will flow like this and over like that out to the WAN or the outside or whatever, because of these values that we've configured on the LAN. If this switch goes out of service, then it'll automatically fail over here with some convergence. Now, what my question to you would be to figure out for the CCDE exam is why we would use HSRP plus HSRP plus RSTP, or STP, I suppose, is the main part that we're talking about there. And what are the different things, like how do you set the HSRP priority? How do you set the span and tree priority? And what would happen if, for example, this 110, if you imagine that was not actually over there, it was over here. This was 110 and this was default, but we still had 8192 and 16384 configured like this. These are the types of things that you need to know in order to solve a little problem, a tiny little problem like that, and these types of things might come up on the CCD exam. Okay, so that's the first scenario that we are going to explain for you that covers like enterprise networking and legacy or traditional networking, I should say. In addition to that, that's only a small part of what would then actually happen if we are to highlight in red. Once we get past this line of demarcation, if that's the layer 3, what happens here? And when I say what happens here in respect to routing. So is it static? Is it BGP? Is it OSPF? Is it a mix of these? Or is it a mix of these? There's so many different iterations in this tiny little topology. Now, from a CCDE perspective, if you blow this whole thing up, you could be talking about 15, 20 or 50 routers, and that's where the challenge comes. So that explains some of the interdependencies between all these different things that we've just talked about on this diagram. Starts off as, should I use spanning tree, should I use HSRP, or should I use stacking or clustering? They're only scratching the surface of what you actually need to do when you're thinking about the holistic network design, which is the whole thing highlighted here in orange. Okay, so that's scenario number 1, and we'll call that STP plus HSRP in the enterprise. The next scenario that I'm going to talk to you about is, let's say you have a service provider core network, okay? So scenario 2, SPL2. And in this service provider network, we have 3 data centers. A big data center down here, or HQ, or main, we'll call that. And then we'll have data center 1 and data center 2. Okay. And then from data center 2, we have some sort of wireless tower to another wireless tower, and then looks like a stick man playing hangman or something, but we are drawing a tower here, and then we have a partner network over here. Okay, so we have a data center with services in data center 1, and then we also have data center 2, which has services. We won't talk about what those services are, but we'll just say that they've got services. Now, data center 1, 2 and 3 all need to be able to talk to each other via layer 2. What we typically see people draw in pre-sales conversations is something like this, L2 VPN. And you're all connected to the L2 VPN, and that's all great and it's happy and it works and there's never any problems and things like that. If you believe that, you believe anything. Don't listen to those pre-sales people that talk to you and tell you that. Listen to the ones that tell you what this actually means and what it means for your business, what it means for your service, and how it actually works technically. Thankfully for you in this video, I'm one of those pre-sales people. If I was working in pre-sales, I would explain to you how it works technically. Okay, so I'm not going to explain because again it's a CCDE level video, but let's say that we have a PE here and a PE here and then a PE here in the core network, and these 3 PEs are linked together redundantly. Now if these are taken at face value and you see that there's only 1 PE, which I'm asking you to do for the purposes of this video, however in real life you might have different permutations. So this PE might be 2 PEs here, 2 PEs here and 1 PE here. So you have something like this. You've got redundant PEs and also links into data center 1 and 2, but then you've only got a single PE router, which is this one, and a single link into your main HQ, and then you might have links to the rest of the world times 30 DCs. Hopefully not, but you might. My question to you then is, if we were to focus only on data center 1 and 2 as highlighted there in black, but I'm trying to change it to orange. So if you were to focus only on delivering layer 2 connectivity between these two data centers, and if we were to focus on delivering layer 2 connectivity between these data centers, when we look at it from this perspective, and we focus only on the devices that talk between the two data centers. From a PE perspective, we have one PE here and one PE here. Then we have two devices here in the data center 1, and we have one device here in data center 2. So this is data center 2, this is data center 1. Data center 1, we have two links, and in data center 2, we have one link. Between PEs, we have MPLS with label switching, so we can do either L2 VPN or we can do L3 VPN. There's only really one show in town here when we're talking about this scenario, and that's L2 VPN. The part that I'm interested in is if this is a layer 2 path end to end, how many segments do we have and what different types of techniques can we look at using? And if we were to split this MPLS network up into different segments, I would suggest that we have segments in the actual data center, because there's other services, remember. We have a PE to CE, this is a CE. Then we have a core aspect, and then we have the PE to CE here on data center 1. And let's just say that they have a common LAN behind them. If I was to say to you, how do we actually deliver an L2 VPN or a layer 2 service end to end in this type of scenario, I'm going to leave this particular video at this stage, and then in the next video I'll explain some potential solutions, some ideas as to how you might actually deliver this without any constraints, because we add constraints into the CCDE as we move along the story. But to give you some ideas on protocols that we might use VXLAN. But remember the context of what we are talking about here. SP networks. Okay, we're in SP networks. EVPN. We might use pseudo wires, or we might use VPLS. We might also use other overlay based technologies. And I'm going to leave that to you to work out and consider what different types of layer 2 technologies and overlay technologies you might actually use. In order to deliver this architecture that I've drawn out, what would be your recommendation? Why would you recommend that? And if you were coming in this scenario from the cold, where you'd never seen it before, what sorts of questions would you ask in order to determine what you actually need to do? Because it's easy saying, oh, we could just use EVPN for that, but there might be a constraint. So what do we need to think about? Support, uptime, migration, and many other things. What's the risk versus benefit? for these different technologies here in a service provider network. I'm going to call this video here and make it part 1 of a 2 or a 3-part series. I hope you enjoyed it, and I hope you enjoy the challenge, and I hope that you also come up with some valid solutions. If you think that you've got a solution and you want to put it in the comments, please feel free to do so. And also let me know if you think this type of video is valuable to your CCDE preparation. All the best, take care, and good luck with your studies.